She really did keep her promise. Okay, so number 10. Somebody tried what to start that? You're using the property that has sine squared. Got to be a sine squared. Okay, so Christoph turn the tangent into sine over cosine. Okay. What can one do from there? Bug, what can somebody do from there? We can multiply the signs. So we have cosecant x plus sine squared x over cosine. We're supposed to end up with secant, which is also known as that. Jordan, what else can we do? Got to do something. You do. Well, I'm asking from right now. We'll go back to the rules of confusion. When you don't know what else to do, where were those? Find something to replace. Is there something there that you can replace? You could replace the sine squared with what? Okay. She replaced something. And we're going to throw it off to Bug up there. See if he can come up with something else. Where are those rules at? Aha. We've already changed things to sine and cosine. There's no like terms to combine. How about combined fractions? So I have a fraction and I have something and there's plus or minus in the middle. It means I can combine them. Right? But the denominator is cosine x, so when I combine them, that's going to be the denominator. That doesn't have cosine x as the denominator, so we have to multiply. And that's going to be cosine squared x plus 1 minus cosine squared x. And I'm going to go over there, come down here. And then what happens, Dominique? Yeah, we should combine these like terms right here, and cosine squared minus cosine squared would be 0, and you would be left with 1 over cosine x, which is secant. In red, over here, coming from this step, I branched off 2 places. I could combine fractions right here, and the denominator would be cosine. And And this doesn't have the cosine, so it would need it, so it would be cosine squared x plus sine squared x. And cosine squared plus sine squared is what? 1. So then I would have 1 over cosine x or secant x. And that's number 10. I didn't copy any answers from the back because there aren't any. In the back of the book it says numbers 1 through 59, answers will vary. So I couldn't give you any more of that kind of help. So any others of the 10? 9. Let me get out of red. Sine squared minus sine to the fourth equals cosine squared minus cosine to the fourth. Okay. I don't remember this one. Ah, I do see something. Okay, what were you going to say? You want to go on the left? And you want to do what? Change them to cosine? Okay. Okay. And we'll do that one in black. Alright, so sine squared is 1 minus cosine squared alpha. What about the sine? Never thought about it. Actually, it'd be sine, which would be sine squared times sine squared. And sine squared would be 1 minus cosine squared minus cosine squared. No, it wouldn't be. Wouldn't be, because it would be 1 minus 2 cosine squared plus cosine to the fourth. We did that. So, but do you want to change them all like that? I mean, we'll see where this goes. This might still work out. I can see one possibility. Does anybody else see it? Have an idea of what to do with that? Like gummy bear? Do you have any idea what you could do with that? No, because there's no division or anything. Here's what I noticed. I don't know if this is going to take us in the right direction or not. But I noticed there's commons everywhere. And 1 minus cosine squared alpha is common. And if I factor that out, I'm left with 1 here. And I'm left with minus a 1 minus cosine squared alpha. Let's see. I don't know if that's going to help us or not. Possibly. I had a different idea. Let's see where this goes. So I have 1 minus cosine squared alpha, and if I distribute that minus sign, I've got 1 minus 1 plus cosine squared alpha. And alpha. 1 minus 1 is 0. So I've got cosine squared. Hey, look at that. And if I distribute that, I have cosine squared minus cosine to the 4th. So it does work. And it makes a nice trapezoidal shape when you're done. Yeah, it's a bonus. There's some places to get mixed up with minuses in the algebra of the thing. So, but did y'all follow that through as we went? The other, number 2 in red. The other thing that I noticed, there's a sine squared common here. And if I take a sine squared out, that would leave me with 1 minus sine squared. Let's see if this will work out. But I think we're still going to have to use Webb's idea and call that a cosine squared, and call that one a 1 minus cosine squared. Okay, so that would have saved us from here to here. It would have taken us directly to there. But same idea. We still have to change everything to cosine, and then we have cosine squared alpha minus cosine to the 4th alpha. So there's 2 ways to do it. And I think we could probably do another one in blue. So this is the difference of 2 squares. So it'll factor sine minus sine squared, sine plus sine squared. And that, I don't know if that will take us to the answer or not. What else did we have? Anything else? Everything else?
Number 3.
3. 1 plus sine alpha, 1 minus sine alpha is supposed to equal cosine squared alpha. Kayla asks, how do you start? Multiply them out? Okay, so we can do first, outer, inner, last. First, outer, inner, last. Davey, what are you going to do with that? Let's take a guess. Look at it and see what you see there. Yeah, you can definitely combine them. Negative sign plus sign is 0, so we're left with 1 minus sine squared alpha, which is, Ray, equal to cosine squared. Any others? 4. Wow. Cotangent squared y. Secant squared y minus 1. And that's all supposed to equal 1? Okay, what'd you try first? It's tangent squared, isn't it? Those are the ones that I keep forgetting. Yeah, secant squared minus 1 is tangent squared. So, well, when you do that, you might notice something right there.
Oh, yeah.
What do you notice now?
I have to deal with cosine. With cotangent, so it's just one over.
Which means they cancel. Cotangent times tangent cancels. If you don't see that, then you would probably follow the rules of what to do next and change everything to sine and cosine. And cotangent would be cosine y over sine y. Oh, they're squared, aren't they? And tangent would be sine squared over cosine squared. And then you would see the cancelings happen. Understand. Any others? Are we good on the other ones? Huh? Ocho.
Mr. McGee,
Yes.
can you send Dominic's version to the office for dismissal, please?
Yes.
Thank you.
They promised to send you back just to take you away again.
Should I remember
Oh. Bye. 2 minus secant squared. That's a good one, Bug. And I see something that y'all probably aren't gonna like. What did people do that tried this? Okay. You change the secant squared to 1 plus tangent squared. Plus. Wow, that's a tangent. Yeah, okay. And then what? Distribute the minus, and you have 2 minus 1 minus tangent squared. 2 minus 1 is 1. It's much better than what I saw. I don't even know if what I saw would end up where. Here's what hit me. So 2 could be rewritten as 1 plus 1 minus secant squared z. And 1 minus secant squared is negative tangent. I guess it would work. But. Alright. So that's this one going into this property to become that, and that one is still there. Any others of them? We're good. 6. Yeah, I was wondering if anybody's gonna ask about 5 or 6. All right, people that aren't asking about 6 and you have 6, what'd you do?
Change the sine squared to 1 minus cosine squared.
All right. So sine squared is 1 minus cosine squared. And then the next thing, Jordan, is what? Let's do that. Cosine squared beta minus 1 plus cosine squared beta. Kayla L., I haven't heard from you in ages. You're very quiet and hide under my radar. What do we do next? Take a guess. Yeah, we should definitely combine them. We have a cosine squared and a cosine squared. That would give us 2 cosine squareds minus a 1. There's another, while you're working these out, keep in mind what's on the other side of the equation, because that's your goal. So if you start to get bogged down, take another look at the other side of the equation, and sometimes it'll give you an idea of what to do next, because that's what you're trying to make it look like. So we are finishing poster, hanging it up on the edge there, and we are making attempts on the same page the next set, which is 11 to 20. Burns, Jordan said to tell you all the ladies miss you.